This is the 16th episode of our Chinmaya Algebra series. For this problem, we're given with the value of P, Q, and R in terms of A, B, and C. And we're looking for the value of PQR minus Q squared minus R squared. Let's evaluate first P squared. We see that P squared is equal to A over B plus B over A squared. And that should give us A squared over B squared plus twice their product, A over B, plus the square of the last term, that's B squared over A squared. This is equal to A squared over B squared plus 2 plus B squared over A squared. So we'll have to remember this. And then if we do the same for Q, we get Q squared is equal to B squared over C squared plus 2 plus C squared over B squared. And lastly, R squared is equal to C squared over A squared plus 2 plus A squared over C squared. So we already know this, and this. So we're only left with PQR. So let's try to solve first for PQ. PQ is A over B plus B over A times B over C plus C over B. We expand this product, first times the first, so that's A. The B cancels out, so that's A over C. Then look at the outer terms, we get AC over B squared. Then the inner terms will be B squared over AC. And the last term would be uh, the last term would be C over A. So that's PQ. To get PQR, we just multiply that thing by by the value of R. So that's PQR equals this times C over A plus A over C. Expand that, it's just quite taxing because these are rational expressions with 4 terms for the first one and then 2 terms in the second factor. So it will be quite an expansion, but we'll have to force our way through it to get the answer. So we'll get 1 plus C squared over B squared plus this and this. We get B squared over A squared plus C squared over A squared plus, next we'll look at this one, that's A squared over C squared plus A squared over B squared plus B squared over C squared, and lastly we have 1. Therefore PQR is 1 plus this bunch of squares plus another 1. Therefore PQR minus P squared minus Q squared minus R squared can be expressed as this one. The P squared has A squared B squared and B squared minus A squared. So if we subtract, actually this A squared B squared and B squared minus B squared over A squared cancels out. So we get here a minus 2 coming from this. And then if we subtract Q squared, the C squared over B squared and the B squared over C squared canceled out, leaving us again with another minus 2 here. The same thing goes for R squared. This one cancels out and this one cancels out, leaving us with another 2. And finally, we add back the 2 ones we have for PQR. Therefore, we have here negative 2 minus 2 minus 2. That's negative 6 plus 2. Add them to get negative 4. Therefore, the answer we're looking for here is negative 4. And that's our final answer. Now, I'm not sure if there's a shorter method for this one, but this is the method that I found that works, and this is quite straightforward, albeit being quite tedious in terms of expansions. If you are in a contest setting where the solution is not required and you don't know how to proceed, or you feel like you cannot completely answer the question within the specified time limit, one quick way to answer this problem is to assume that the answer is invariant, meaning regardless of the values of A, B, and C. Of course, the solutions for P, Q, and R is likely in terms of A, B, and C. So when we say invariant, it means that the answer is the same regardless of what or of which values of A and B and C we choose. So if that's the assumption, we can actually assume here A equals 1, B equals 1, and C equals 1. So if we substitute it here, we get P equals 2, Q equals 2, and R equals 2. And then lastly, we plug that in to the required expression. We get PQR as 8 minus P squared is 4, Q squared is 4, then R squared is 4. So if we subtract this, we'll get negative 12. So if you want the quick method for this one, you can use that. You can use this method, but I'm not into this method because one, we cannot assume that the answer is invariant in terms of the other variables. So if the answer here is actually not a constant and the answer is in terms of A, B, and C, then our answer of negative 12 would be definitely wrong. And second, I'm not advocating this method because if the solution is required, this will not be accepted because this does not guarantee that the answer is negative 4 for all values of A, B, and C. So this is just a quick method that works if the answer is invariant. But still, there's a value in expanding this one. So I'm still advocating that we try to always look for this correct, quote unquote, correct method of answering this type of problem. That's it for this video. I hope you learned something from this, and please subscribe for more content.